you can use that sensor data to even recognize when something may go wrong, and in the most advanced sense, think about corrections that can be made on the fly, or preventative changes that can be made to the process depending on the sensors that you happen to be monitoring as it goes. The EOS machines are connected with many different sensors. The systems can also be connected to a network, so you can do things on the fly as well. And there's really a lot of power there in anomaly detection. And then the last one is image recognition. So image recognition, also a powerful tool, slightly different than anomaly detection in a data set, but image recognition using AI is getting better and better over the course of the last year. And taking pictures of the process as it's going. This can apply to an EOS printer, can apply to a dental graft, like the example we just saw, can really tell you a lot about how the process is evolving, indications of things that are going well or maybe not going well, and give insights into changes that may need to be made. At EOS, we work in all three categories, and what I want to do now is show you just a glimpse of some of the things that we're prepared to talk about in a public way. And hopefully you can see some of the steps that we made. Hopefully it spawns a bit of a discussion. So the first is a knowledge management tool. So you see here a kind of screenshot in the center of a knowledge management tool that we've created. This is a ChatGPT EOS interface style chatbot. But of course, it's trained with EOS manuals, with service reports, with reports that show how different machines have been fixed in the field, and most importantly, it's able to maintain version control. So EOS printers have been around for 35 years. Like I've said, there's of course many different versions of an M290 out there, many different versions of an M400-4. How can you be sure that the correct maintenance procedure is via this tool to the correct machine? This large language model interface really helps our service team do knowledge management in a professional and efficient way that used to take many calories in terms of alignments and sharing and internal trainings. This has been a huge help and a huge impact for our service team in particular. The second is in image recognition. So we talked about this. Our machines are equipped with multiple different types of cameras. One type of camera is something which we call OT. Our OT cameras are detecting a certain wavelength of light that's coming out of the process bed surface as the parts are being printed, and using image recognition, we're able to capture these images layer by layer, which creates, of course, a database that we're able to build. We're able to infer then from that data a fingerprint of a good design that's been done. We're able to also make changes on the fly. So if there happens to be a section of a part which is maybe not getting hot enough or looks a bit cold, or a section of a part which looks like it may be overheating, there are some on-the-fly changes that the system can make to correct the printing process as it's happening. And then where AI really comes into play here is, without measuring the images, can you predict the images and predict the future of the printing process? And here you get into using true AI algorithms to predict the printing process, and therefore you can very accurately simulate how things are going to progress. This is really advantageous, if you have a critical part of a build going in the direction of first time rate, going in the direction of trying to democratize the complexities of 3D printing in general, right? It no longer needs to take, an industry veteran who can look at a part and determine exactly how to print this component